This problem is designed to teach the binomial distribution. A packet of lettuce seeds is guaranteed to have a 95% germination rate. I planted 20 seeds in my winter garden. Find the following. Now it's binomial because I have a success or a failure. The plants either germinate or they don't. I've got a fixed probability of success. I have a fixed number of observations, and I believe that the plants will germinate independently of one another. That may be a little bit iffy. If I forget to water, they probably all will die, but let's consider that as an assumption for this problem. Letter A says find the probability exactly 17 germinate. That's the probability that x equals 17. The work is going to be 20 choose 17 times the probability of success, and I need 17 of those, times the probability of failure, and I need 3 of those. Now that's what I'm going to write, but what I'm actually going to do is the binom PDF of n p x. Kind of running out of room here. It's hard to write. Oh, look at that. I can just slide it over a little bit. Check this out. Give myself a little bit more room. 17. So on my calculator here, I'll go here to the binom, that's second distributions, binom PDF. The number of trials is 20, 95%, 17. There's my answer. So that's what I'd write right there, 0.05958. Now I wouldn't necessarily have to write this portion on a test because that's not really work, but the rest of these things I need to write down. Now on the next part, they asked me the probability that all 20 germinate. So that's the probability x equals 20. I really don't need to write the formula again because I've already done that. The formula is 20 choose 20 times 0.95 to the 20th times 0.05 to the 0. You don't have to really write that. It's the binom PDF of n p x, and I don't really have to write that either, but on my calculator, I'm just going to change that 17 to a 20, and that's the probability they all germinate. So this answer right here is what I'm looking for this problem. And again, this stuff here is not necessarily written down. I don't need to write that. Letter C says what's the probability? Fewer than 10 germinate. Fewer than 10. Less than 10. That's the same thing as the probability that the number of seeds that germinate is less than or equal to 9. Again, no work is needed because I've already done work. So it's the binom CDF NPX. So on the Wabbit, second distributions, binom CDF, the cumulative density function. There it is, pretty small, and this shouldn't be a surprise because the seeds have a pretty high germination rate. 95% of them germinate. So there's my answer here for this one. It's this very small number. I don't care if you write it as scientific notation or like that. Either way. More than 15 germinate. The probability, the number that germinate is bigger than 15. Now since it's bigger than, I need to do a cumulative because it's got an inequality, but since that inequality is greater than, I've got to do a complement as well. The question is, what number goes right here? What number is that? So if I look over here on this side, I'm not including 15. I'm not including 15 right there, which means that I need to include the 15 right here. So that's got to be a 15. So then this is going to be 1 minus the binom CDF of 20.95, 15. Again, on the rabbit, or the wabbit, I guess, that's the binom CDF of 20.95, 15. And then really, I need to look at 1 minus that number. Darn good chance that at least more than 15 of them germinate. That's more than 15 of them germinate right there. Next part says find the mean number of seeds that germinate. This is a binomial problem, so the mean, which is the expected value, is NP, which is 20 seeds, 95% germination rate. Multiply those out. I expect 19 of them to germinate. If that was a decimal, that'd be okay. Leave it as a decimal. Standard deviation is the square root of n times p times 1 minus p. Some places you'll see this written as, 1 minus p. Sometimes you'll see this written as the square root of npq. Q is the same thing as 1 minus p. So this is the square root of 20 times 0.95 times 0.05, which I cannot do in my head. So 20 times 0.95 times 0.05. That, I probably could have done that in my head, huh? That number is actually the variance. So I need to square root that to get the standard deviation 0.9747. So there's a fairly comprehensive way of looking at a binomial distribution.